Hey, we're going to continue with our discussion and overview of our forces test review. Move this down. So our next one, we have a boy pushing a 200 Newton lawnmower tilted at an angle. We've got to figure out the acceleration of the mower given a coefficient. So this one, we have a 200 Newton mower, so that's our FG. 200 newtons. We have the angle, 35 degrees, so that's this, with 500 newtons. And we've got to figure out, we know there's friction acting backwards. FFK, we got to find our acceleration. Alright, so how do we do this? Well, first, anytime you see an arrow and an angle, you break it apart into FAPPX and FAPPY. FAPPX is going to be 500, which is our hypotenuse, times the cosine, if you look in your equation sheet, of 35. 500 cosine 35, 409.58 newtons. 409. FAPPY, same idea, 500 cosine, sine 35 equals 286.79 newtons. 286.79 newtons. Alright, so we have, sort of redraw this, we have two forces acting down. We have FAPPY and FG. 200 for the FG, 286.79 for the FAPPY. So FG is our smaller force, 200, and FAPPY is 286.79. Our normal force has to take care of both of those, so our normal force is 486.79 newtons. We have our applied force, which is pushing across the table of FAPPX at 409.58, and our force of friction, which we still do not know. We know it's FFK. Alright, so our FFK, though, by following the equation, mu k times the normal force, we can calculate. We can figure out that mu k is 0.3 times our normal force, 486.79. 0.3 times 486 is 146.04. That's 04. That's newtons. 0.04 newtons. That is our force of friction. Alright, so we're trying to find the acceleration. We know that mass times acceleration equals the net force, and the net force equals our total right, which in this case is just the FAPPX, minus the total left, our FFK. Our mass we don't know, but we know the weight is 200, so mass is FG over 9.8. FG is 200. Our mass is 20.41. I know I'm going fast on this one. So you can replay it as many times as you need to. That's the nice thing with these screencasts. 20.41 kilograms. So our mass times acceleration is 409.58 minus our force of kinetic friction, 146.04. 409.58 minus 146.04 gives 263.54. So 20.41A equals, times A, sorry, is 263.54. A is going to be 263.54 divided by the 20.41, which is, in this case, a high number, 12.91 meters per second squared. In this case, as drawn, would be to the right. Good. Hopefully that helps with that problem. Go right on to number 9. We have a 300 Newton sign hanging due to 3 ropes. One is purely vertical, and the other has a tension of 300 newtons. The other 2 ropes are at 55. That's supposed to be degrees. Degrees. Above the horizontal, one up and to the left, one up and to the right. What must the tension be for each of these ropes in order for the sign to be in equilibrium? Equilibrium, remember, means that F net equals 0. All the forces cancel. So we have Fg equals 300 newtons. We have one rope which has its own tension force of 130 newtons. We have 2 other ropes, one at 55 degrees this way, one at 55 degrees that way. Alright, so this gets a little tricky in some ways. I'm going to make these bigger just so they're a little easier to work with. Alright, so both of these ropes, both of these extra tensions, Ft, and so I'll call this one Ft left and Ft, I'm running low on room here. This one is Ft to the right. So Ft left, Ft right. Both of them have components. One of them is to the left for the Ft left, but it also is up for Ft left up. And then same goes for the right. One is to the right, one is up. So we really have 3 forces to the up. We have this one, and this one. And we have 1 force to the left, 1 force to the right. We know that those cancel because our net force is 0. So whatever that number is, honestly, we don't care about right now. We know that they cancel. So all of our up forces have to equal 0. I'm going to call this one, it's Ft R Y. Vertical right tension force. And then this one, running low on room, it'd be Ft Ly, vertical left tension force. So we have 3 forces up. Our total net force is all of our vertical forces. So we have 130, which is the initial Ft, plus Ft Ly, plus Ft Ry has to equal, minus our down 300, all has to equal 0. So that tells us that Ft Ly plus Ft Ry has to equal, I just sort of skipped a step, so, do 130 minus 300, bring it over to the other side, is going to be 170. Okay. This is where we have to think a little bit more. Since both of these are at the same angle, that means that both of these have to have the same vertical tension, because if this one had a different vertical tension, then it wouldn't be at the same angle. These have the same lengths in terms of forces, because forces are vectors, so they both have to have the same side. So these 2 forces really equal each other. Ft Ly equals Ft Ry. So that just means that I have 2 Fty forces, L and Y, equals 170. So each of those forces, this one and this one, have to have a total value of Fty equals half of that, so 85 newtons. So there's an 85 Newton force here, an 85 Newton force, 5 Newton force there, 85. So let me redraw now that we have that, because it's a little sketchy here. So just trying to zoom in a little bit. Here's our sign again. We had a 300. These are all tension forces, so I'm just going to drop what they are. Drop all the labels. We had one which was the 130 given, and then we have 2 which are equal length of 85. Alright, so just going to zoom in on one of these 85 because they're part of the triangle. The tension force is truly the hypotenuse of the triangle, but all we know is the vertical piece. We know that's 85. But we know another piece of information about the triangle, and that's this angle, 55. So we have two of the three parts that we need. If you have two of any three parts of the triangle, you can find the third. So we have the opposite side, and we have the angle. We're looking for the hypotenuse. So opposite and hypotenuse, looking on our sine SOHCAHTOA, that's going to be a sine. So we can set this up just as an equation. I know a lot of times in the past we've done FT, we knew that, and we're looking to break it apart into the vertical and horizontal using the sine. It's the same thing, except instead of solving for O, we're solving for H. So let's go through that. You have the sine of 55 equals opposite side, well, we know that, 85, times, over the hypotenuse, but we don't know that, FT. So we can solve that for FT. The first step is to multiply both sides by FT. So you get FT sine 55 equals 85. Then the next step is to divide by sine 55. So FT is 85 over sine 55, because sine of 55 is just a decimal. So you can do 85 over the sine of 55, which is going to give us a tension force, which is our hypotenuse, of 103.77 newtons, and really you should formalize it to say at 55 degrees above the horizontal. So both of them have the same angles. The tension of each rope is the 103.77 newtons. Good. I'm going to see if we can get through this one. Question 10. Very similar, because we have, that's not 480, that's 48 degrees. We have door and boots, they're trying to jump. They make 48 degrees with respect to the vertical, so that means 52 degrees with respect, is it 52? No, 42 degrees. I may have told you something wrong in class. 42 degrees with respect to the horizontal. And that's the one we're going to look at, because we like BHs. So, they're on the vine, it's 42 degrees, and that vine has a tension. It's the tension force trying to pull them up, and it has to hold their weight. So their weight, which is acting down, 42 times 9.8, is 411.6. So their weight is 411.6 newtons. So the vertical piece of this, because this tension is really going up and then over, has to be also 411.6 because they're being held up by the vine. So we've got to find what the tension is. It works exactly the same as what we just did. The tension force, which is our hypotenuse, is here's our 42. So it's 411. Sorry, I just lost my train of thought. Our 42 degrees. We know our angle. We know our opposite from that angle, and we are looking for our hypotenuse. So again, that's sine SOHCAHTOA. So we can set it up. Sine 42 degrees equals opposite, which is the 411.6, divided by FT. And just like I did in the last one, I'm not going to show all the steps again. Your FT is going to be 411.6 over sine of 42, and I believe possibly even in the solutions I handed out, I'm not sure, I might have gotten the wrong number, but this one I know is correct, over sine 42. The tension is going to be 615.13 newtons. And there we go. So it's again very similar to their to the problem 9, sort of using sine and cosine in an opposite way, or really just sine. Their weight, by the way, we answered when we did 42 times 9.8, and the tension 615.13 at 42 degrees. All right. Hopefully that helps. I'll try to finish up the next couple in the next screencast.